Okay, guys, real quick before we start, make sure you are in the GitHub organization. If you're not, don't worry. Just come up to me after class and just let me know that you're not. To check that, you just go to github.co.cis.cornell.edu. Different than the normal GitHub, and yeah, you gotta log in with your NetID, and then you gotta check under your organizations to see if you've been added. It should be called uh, Intro to iOS, something like that. You should see it there. Okay, cool. So yeah, then also check to make sure you're in CMS. I added people that were in the ed discussion to CMS and the GitHub today around 1 or 1:30. So if you did join the ed discussion after that, you were not added yet, so no worries. We are not going to be using GitHub for this first assignment just because people are going to be moving in and out. So we're just going to make sure everyone's all set before we actually use GitHub. So this will be important for the next assignment, but that doesn't mean that you should slack on it. Really make sure that you have everything that you need for the next one. And CMS is very important. One more thing about GitHub is I can't add you to the GitHub unless you have already set up an account with CoCS. So all you have to do for that is you just have to log in once with your NetID onto this site, and then I'll be able to add you. There were a couple people that I tried to add but did not, haven't ever opened it, so I wasn't able to add you guys. So yeah, okay. Cool. Oh yeah, also one more thing, download Xcode. I put a reminder on Ed about this. It might take a while, so you might not be able to follow the lecture if you start downloading it right now. Maybe, hopefully, fingers crossed, the internet in here will be fast, and yeah. Keeping the notes up on your computer. Just see real quick. Cool. All right. Okay, cool. So yeah, this is Intro to iOS Development. Make sure you're in the right place. This is our first lecture. Last time was lecture 0. Today we'll be going over the Swift basics. Swift is a programming language. And yeah, just to kind of introduce myself again, I am Peter. I'm one of the co-instructors this semester. And
I'm Val, and the other co-instructor this semester.
And we're really excited to have all you guys. Okay, so quick, just a couple important things. Join the ed discussion. QR code's right here. I actually had the incorrect GCal last time. That was for all of the app dev courses. That might not be too helpful to you guys, so I made an actual GCal with just iOS stuff. So everyone scan that and add that. That just has office hours and our lecture times. And then for the partner matching, if you do want to partner on A2, A3, and A4, make sure to fill out the partner matching form. There's no partners for A1 because it's a very basic assignment. Cool. Yeah, so just, scan those. Yeah, questions? What's up?
QR code for the GCal doesn't work.
Oh, yikes, okay. What does it say? Does it say something?
It says unexpired.
Oh, geez, okay, yeah. All right, yeah, okay, I guess that's what happens when you use a free QR code. So, okay, I'll get the links updated. Join the ed discussion. I think a link to the ed discussion should be in your emails somewhere. I can, if you don't have an email from me with information about the course, then just come up to me after class and I'll give you the ed discussion invite. And then I'll post everything else in ed discussion. And I think the partner matching is already in ed discussion. Okay, cool. And this thing doesn't want to work. Okay. Yeah, so announcements real quick, kind of what I already said. Join the discussion. Just set up Xcode and Git and GitHub as soon as you can. Yeah, so A1 is submitted on CMS, but A2 will start using GitHub. So office hours are going to be released pretty much now. I'll release them right after class. They should already be on the course website. So yeah, those are starting tomorrow. Cool. And then, yeah, if you have any issues enrolling, just let us know. And also, like I said earlier, if you are not in GitHub or CMS, please check both If you're not in either of those, just come up to me at the end of class and I'll get your name down. Okay, awesome. So kind of a recap of what we did in lecture 0. So we just told you guys a little bit about Git. So Git is a version control system that allows us to kind of track our changes in our code that we make, and also allows us to collaborate, which is pretty cool. So one more thing is Git is a software, GitHub is a service. So Git is the software that runs, and GitHub is the place where we put all of our Git repositories. And then the kind of stage of like what you have to do is first you pull from GitHub. So you have a repository on GitHub, you pull from that repository and you get it on your local machine. Then you make changes to that on your local machine, and then you have to do these 3 things to put it back up onto GitHub. You have to stage, then commit, and then push, and that is right here. So stage, you do git add dot, that just adds all the files. Commit, you do git commit, and then this flag just says I'm gonna put a message, and then you put your message there. And then when you want to push it back to GitHub, you do git push, and that pushes it back to GitHub. Awesome. Any questions about that before we move on? Cool. Okay, so yeah, now we're gonna kind of go into a little bit about the programming language Swift. So Swift is, basically Swift is a programming language. What I'll be doing is I'll be using Xcode Playground for this. I'll show you guys how to create a playground. You will pretty much never have to do this after this lecture. This is literally just to show you guys how Swift works. Cool. So I'm going to do that real quick. Okay, so you're here in Xcode, and like once you open Xcode, you'll probably see something like this. And what you're gonna do is you're gonna go over to File, and then hover over New, and you'll see that like right down there, kind of halfway down, I see something called Playground. So you're just gonna do that. Then you're gonna name it, or first you gotta select which playground you want. We just want a blank playground for this. And I'm gonna name it Lecture 0, or Lecture 1. Perfect. Okay, cool. Let's make this a little bigger. Okay, so kind of the first thing that you'll notice is we have like 2 different sections here. We have this kind of like sidebar area, and then this is like where we write all of our code. So the first thing I wanted to go ahead and demo is the variables and constants. So essentially variables are in any like kind of program that we create, we will need to store some type of data so that we can use it later. So in Swift, you can store variables in 2 different ways. You can store it either as a variable or as a constant. And so essentially what that means is let me go back to my slides real quick. This is probably easier to put this up here. Yeah, so basically variables versus constants. So both of them store data, as I said before, but variables are mutable. So what that means is that the data inside of a variable can be changed. However, the data inside of a constant cannot be changed. Once the constant is set, it's set. That's it. And that's what's called immutable. So mutable versus immutable. Yeah, so pretty much, yeah, we always use a constant unless our value needs to be changed. That's pretty much the rule of thumb. And basically in Swift, we create a variable using the var keyword, and we create a constant using the let keyword. And so let me go ahead and just demo that real quick. Okay, so we make a variable using var. So var, I'll just say instructor, if I can spell, equals Peter, right? So this is a variable here. And if we want to go ahead and change it, we can. So you see, I defined it as Peter, and then I changed it to Bell. And we can do this with variables. But let's say I had a constant. I defined a constant using the let keyword. So let we'll just change this to let. So same thing, I'm just changing it to let. What you'll notice is that Swift yells at me and says, hey, like instructor, I'm missing a letter there. Dang, you guys didn't tell me? Okay. Yeah, so instructor is a let constant. So it knows that it's a constant, and it yells at you. It says, hey, you cannot do this. So that
We have a
is...
question.
Yeah, what's up?
Show like how to make that playground again.
Oh, yeah, sure, of course. Yeah, so what you're going to do is like when you have Xcode open, no matter what your screen looks like, you should have file in the top. And you just go to new, and then you'll see playground is about halfway down there. Yeah. And then...
Do you have it, or do you want us to show you again?
All good? File, playground. So you have to open Xcode first. Yeah. Cool. Yes, and once you're here, you're going to click this blank one, and you can name it whatever you want. Oh, geez. This thing's being interesting. Okay. All good? Cool. Nice. So, yeah, just to kind of reiterate, like you can think of like a stretch of road, right? So, like an example of a constant would be like the speed limit on that stretch of road, right? Like, I know sometimes the speed limit changes, but we're just going to think about a stretch of road here. So the speed limit is 55, but a car doesn't have to go 55. It's not set at 55, right? Its speed changes. So the speed limit would kind of be a constant, and then the car's speed would be a variable. I know my car's speed is definitely very variable, especially on the highways. Yeah, okay, so cool. So yeah, so next is kind of the data types that Swift has to offer. So like we just described what like a variable was, but there's like different types of data that can be stored inside of a variable, and that's what are called data types. So yeah, there are many different types of data that Swift can handle. Let's go ahead and show a couple examples. So I'm just gonna remove this. Okay, so first is like a integer. So this is just a number that's like an integer. And so you can just do var, let's see, var grade, because I know everyone's gonna get 100. Yeah, you can do var grade equals 100. You can also do let as well, but we just described what the difference is between let and var. So then you can also do a decimal number, which is also called a double. You can say var, let's say like a price, for instance, like total price equals 1.21. So like $1.23 would be like the representation there. Cool. And then you can also have strings, which are just like letters. And so you get like var message. Let's say I had a message that I wanted to tell someone, and the message was hello, right? Cool. So yeah, so Swift is basically like okay with us writing all of these out like this, because these are like what's happening on the right is the like it can infer this type that the variable is supposed to be on the left. So essentially, let me show another example. So let's say that we want to first like define the variable message and set it later. So what I'm gonna do is I'm gonna say, hey, like this variable exists, and then I'm gonna say like later, hey, like this variable has this in it. So let's try to do that real quick. So let's do like message equals hello, and then I'm gonna remove this from here. Okay, great. Let me try to do something real quick, see if this will be better. Again. Okay. So yeah, so what I'm gonna do is I am gonna define the variable. So I'm gonna say like var message exists, and then I'm gonna set it later. And so what you notice is that when we initially define it on line 8, Swift is gonna yell at us and say that the type annotation is missing. So essentially, the reason it's yelling at us here is because we said that var this var message exists, but Swift is what's called a hard typed language. So what you have to do is you have to say what the what the variable is if it can't infer it. So in the original example, like let's say those examples up above, Swift can infer that total price is a double because we gave it a double, right? If that makes sense. But here we didn't give it anything. So it has no idea what message should be. So it's gonna yell at us. So we just have to do this. And what this does is this tells Swift exactly what the type should be. And then we can set it later. Also, one important thing to know is that you can like, once you set like the type, you can't just go and like set it to like the variable to a different type, Swift will also yell at you for that because it expects that message should be a string. So if you try to set it to like an integer in this case, then it won't work. Okay. Awesome. Yeah. Any questions about this before we move on? Awesome. Yeah, and if you have any other questions that you don't want to ask right now, please feel free to come up after class. Okay, so, okay, still recording, that's good. So basically, yeah, to reiterate, it's statically typed, which means that there's type safety. So Swift will basically try to guess what the type is, or it'll yell at you for not knowing what the type is. So it basically prevents us from putting values inside of like a variable that shouldn't be there. And yeah, you must provide the type at the compile time, or the type must be inferred. So it'll yell at you if like it can't infer the type, and you just have to explicitly say it. Cool. And then to go over like the data types, we have integers, we have booleans, we have strings, and then we have floats and doubles. And basically the difference between these two is just like how much storage each of them uses. And they're a little bit different in their representation, but we don't need to worry about that. Cool. Okay, so yeah, some operators now. So basically there's some very like basic operators, such as like adding, subtracting, multiplication, division, also modulo, which is that percentage sign right there. So real quick, before we move on in this slide, I want to just show this. So you can do very like simple like addition, like 5 plus 7. And if I run this code right here, well, I also probably should have explained this a little earlier, but what you'll see is the output shows on the right-hand side in that little box there. So like the output for the line 2 is going to show over there. 5 plus 7 is 12. I think that checks out. Then we can do multiplication. And we can do like 5 times 7. This should be like 35, and it probably will be. Yep, cool. And then division. We can do like 10 divided by 2. That should be 5. Yep. Man, I'm really flexing my mental math here. Yeah, so then there's also some like other types of division we can do. So like a different division, let's say like, let's do like 5 divided by 2. So this like doesn't come out to like a nice round whole number. And what you'll notice is that, if that goes away, okay, there we go. What you'll notice is that Swift rounds down. So this would be like 2.5, right? But it shows 2. And that's because we have 2 integers here. So it's going to give us an integer. If we give it 2 integers, it's going to return us an integer. If it gives us 2 doubles, it's going to return us a double, right? So let's say I have a, I'm going to divide an integer. So I'm going to say like more different divide. So let's say I have like a double, right? Like 5.0, right? And let's say now I divide 2 from that. I wonder what Swift is going to give us now. I actually know, it's 2.5. So the reason it's 2.5 is because we gave it 1 double, we divided by a int, and it's giving us back a double. So when you use like when one of the numbers is a double, it's going to give you back a double. So it can do this with like the opposite way too, and we get back 2.5 still. Awesome. Okay, now real quick, you can actually use the like addition operator on strings, which is pretty cool. So you can say like hello plus class, and what we get back is hello class. Cool. But let's say that we wanted to add a number to this, right? So like I want to say like hello class 7, right? What you'll notice is when I try to do that, it's going to say that like it can't add a string and an integer, right? So this is the string, this is the integer. It doesn't know how to do that. So what you would have to do is you would have to do what's called type casting, which says, hey, like I know this is an integer, but I want to make it into a string, right? So you do string like this. This is how you would typecast, like this. And so basically like this is one way you can do it, right? but it might get a little messy. If you have like a bunch of integers going on inside of your strings, you're gonna be casting all over the place. You're gonna be writing out the word string a lot. It's honestly, it's not great. So what you can do is to do it a little differently. Is you can do something like this. So what you can do is you can just write out the string, like hello class, right? But then let's say that I want like my 7 to go right here. You can do something called string interpolation, which basically says like, hey, like it does exactly what's up there, just a lot easier. So you can write the values directly into Swift by doing this syntax. So you do a backslash and then an open parenthesis and then a close parenthesis. And you'll notice that it got like white, right? So what you can do is you can put like a lot of things in here. You can put like a variable, you can put like just a number, you can put whatever. So I'm gonna put 7. And what you'll notice is that without having to typecast or do any of that stuff, we get hello class 7, right? Awesome. And so you can do this with a variable as well. So let's say I wanted to do like var num equals 7, right? You can put num in here, and we'll get the same thing. We'll get 7. You can do this with a bunch. You can do this with different variables. You can do this like 7.0, hello class 7.0, perfect. Yeah. So this is the way we want to do it. We don't want to do it this way. This way is a lot cleaner. It's a lot nicer. Awesome. Okay. And yeah, just going back to the slide. Yeah, so yeah, these are like the basic operators. I didn't show like modulus, but modulus, what that does is it gets the remainder. So let's see, like 5 remainder 2 would be like 1, right? Because if you long divide 5 and 2, you get 1 as the remainder. So that's kind of like what that percent sign does. And then, yeah, so like I said before, operations on 2 integers will give you back an int. Operations on 2 doubles will give back a double. And if you have 1 double and 1 int, it'll give you back a double. And yeah, typecasting, kind of what we explained before. It basically like it doesn't change the type. It just produces the value to be used for that operation. So we cast it to like a string. And then yeah, we want to use like string interpolation to glue strings with like other variables, kind of like what I showed. And yeah, it just replaces the plus operator. It makes it a lot nicer, makes your code a lot greater. Yeah, what's up?
Can you add in some doubles?
Yeah, I'm pretty sure you can. That's a good question. Let's actually try it. Let's do like 1 plus 3.0. You can, and it looks like interesting. It gave us back an int here. I wonder if okay, so it looks like it's giving us back doubles. Cool, awesome. So you can. Any other questions? Okay. Good. I'm just gonna make sure this is going. Okay.
Wait, so these are like the common operators, but just one thing I want to call attention to is that if you've programmed in Python, you might have been using and, like the English word and or for logical and or, but in Swift you want to use like double ampersand and also double bar for and or. But yeah, everything else should be basically the same for any other programming language. Okay. Okay, so the next thing we'll talk about is data structures. So far, we've only looked at storing very simple data, such as text and numbers. But what if we want to store more complicated data in a more specialized manner? This is where data structures come in. I think the first thing we should look at is arrays. So if you've programmed in another language, like Python, etc., or just in general, if you have a list of items, in Swift we call these arrays. Go to the, where's your playground? Okay. Okay, cool. So I guess we can create an array of strings, and let's just call this var staff. And so let's see, Peter and Bell with G. And so here we have an array. It stores 3 strings. And in Swift, suppose you want to access an element of this array, you want to pass in a position. And in Swift, arrays are 0 indexed, which means the first element of the array will be index 0. So if I wanted to get Peter out of the staff array, you would do staff and then pass in the brackets 0, and then if I run this, it should give me Peter. And so that's accessing an element of array. So similar to other languages, if we want to reassign and modify the first element of the staff array, we can do staff 0. And so staff element index 0 gets, for example, let's put Caitlin in here. And so if I run this and then look at staff again, it should have changed. And so let's say I want to look at staff 0 again, just to show you how it changed. So now it shows Caitlin instead of Peter. Like suppose you wanted to add an element to this array, there is a way you can add it using the append operator. So you can, suppose we want to add Charles. So now, suppose I want to look at, this would be 0, 1, 2, 3, the third person in this array should give me Charles. Cool, so it gave me Charles. Okay, yeah, so, and then initializing arrays in Swift. So there are 2 ways you can initialize array in Swift. First you could do var like array, and you could just, let's suppose you want to store like array of strings, right? So we give it the string type annotation. You could first initialize it this way, and cannot convert type any to specify type string. Let's just do it.
Brackets around the string.
Hmm?
You gotta put brackets around the string.
Oh yeah, sorry. You have to put brackets around the string. And so this is one way you can initialize an array of strings. But the second way you could do this is array2 using the string a constructor like this. And then I guess seeing. And so like let's say I pass in the value of Peter into my string. Okay, yeah, I'm not sure why it's doing that, but the point is, in order to append a, in order to call append, you should have an like at least an instance, like an empty array. So I guess if we do append here, array.append bell. This is good, but this should give us array 0. Okay, so earlier also we were talking about how with type inferencing and like how Swift is statically typed, we have staff storing an array of strings. So that means that if you try to add in or reassign an element of the array to a different type, like Swift would yell at you. So doing staff, for example, 0 assigned to 2, Swift would yell at you. Cannot assign value of type int to subscript of type string. And like suppose you wanted to be able to assign, have like basically elements of different types, you could have staff be type holding type any. So if we did staff holding any, this error should go away, like that. Okay. So do you have any questions?
One thing that I'd like to highlight real quick, guys, is you see that like here, she does assign a variable, like the variable array to a value, which kind of goes against what I like said earlier. And the reason for that is because like Swift, if you say like empty array, it can't infer what the type of that array is because it doesn't have anything in it yet. So you have to tell it what the type is so that it knows, if that makes sense. Any questions about that? Like why here we have to provide this even though we're declaring a variable? Cool.
All right. The second thing, another data structure we'll talk about now is dictionaries. So the difference between dictionaries and lists is that in list, I guess the way it's ordered is you have indices, and at the 0 index you have an element, at the first index you have an element. So it's kind of in a way an implicit tuple between the index and then the element that you're storing. Versus in a dictionary, you can have like a mapping between the key and the value, but the key doesn't have to specifically be integers. So the key can be literally any type, as long as it conforms to the hashable protocol, which means it's a unique identifier for each key in the dictionary. And so that provides more flexibility, which is maybe a reason why you might want to use a dictionary. And so I guess an example could be var like staff ages, and type annotation looks like this. So we want to map each like person on iOS staff to their age. So we want strings mapped to type integer. So string to int. And then we can initialize and add stuff into our dictionary like this. So for example, I'm 20. So this would be what it looks like. Think Peter is 20. So this is what this looks like. Yeah. And then if I wanted to get a value out of my dictionary, I would have to pass in a key. So in this case, the keys to my dictionaries are names. So if I want to get my age, so Belle's age, out of the dictionary, I can take my dictionary, staff ages, and pass in the key Belle. And then this bar should store my age. So it stores 20. I guess like to show you the difference, like let's put like 25 here, just so like I'm not tricking you. So here it still stores 20. Okay. So do you have any questions about dictionaries? Okay. Oops. Wait, where's
There, sorry, it's right there.
okay, this one?
Yeah.
Okay, cool. Okay. Yeah, we talked about type inferencing. We talked about like the purpose of arrays, so storing a collection of values. We also talked about how dictionaries store more pairs of values, and they can be more flexible. So with no questions, we'll move on. Okay. Now we'll talk about conditionals. So suppose you wanted to execute a block of code only when a condition is met. And in this case, you would use something that's called conditional. So in other languages, or just like universally, it's like an if statement, else if, and else. And then inside conditionals, you can check for conditions that can be kind of complex. Not just necessarily like, if true, do something. It could be like, if like Peter is 20 and Richie is 24, do this. Or if Peter is 20 or Richie is 24, do X. Else if, like, Peter is 29, do X type of thing. So you can use lots of if and else ifs and else to make a more complicated logic depending on the condition. So I guess we can do an example right now. Okay, so let's suppose we have a variable a and it gets value 0. So if a is, for example, 0, we print we can print hi. Else print hi. So we can run this. So we print hi because a is 0. However, let's see what happens when a is not 0. So like a is 4. So we get by. So this is a pretty simple case, but let's suppose like if it doesn't meet the first condition on line 46, we want it to go into another block of code. Well, in this case, instead of just having like an if and an else, we can have an if and an else if and an else. So for example, we could do maybe if a is 1, print welcome. And then the else, so the else will be executed if the first if statement the second, if first if statement is not satisfied, the second else if is not satisfied, then the else will be executed. So, for example, we already know earlier that like if A is 0, we'll go into the high block, printing high. But if A is 1, we'll go into the else if block and print welcome. And then if A is not either of these, so if A is 2, we would go into the else block and print by. So we'll print this out. And so the else is kind of a catch-all, and that means that if you're not 2, or if you're not 0, you're not 1, and you're equal to 2, 3, and onwards, or like negative 1 million, you would be printing by. So it's basically anything that's not the first two conditions, you would print by. So in this case, let's put negative 100, we should print by. Okay. Okay, so now want to talk about something called a guard statement. And so a guard is kind of like an inverted if statement. And so an example would be, let's say this is 0. So we can type if guard A is 6, else do something. You can print bad. One sec. So and what this will do is it checks a condition, is A equal to 6? If it's not equal to 6, then we go into like imprinting bad. However, if A is equal to 6, then we can continue. So you can kind of think of it as a wall. If we satisfy the condition, let us pass through this wall. So if we satisfy the condition that A is equal to 6, keep going and execute whatever is after this guard block and on the next line. However, if we do not satisfy the condition, we should go into the guard block and not be passed. And so it basically filters out like bad values that you don't want to continue to keep going, like an inverted if statement in a way. And so usually it's telling you guard body must not fall through, etc. Normally, like maybe you want to like return or like throw an error in this case because it's essentially saying like if you haven't satisfied the condition, don't continue executing statements after this program.
Question. What's up?
Yeah, so what's the difference between an if and a guard?
So you can achieve pretty similar things using both. It's just we use guard in certain situations, like Belle said, where like you want like a wall that says like, hey, this better be true, or else I'm not like doing anything else under it. And so that's why it's yelling right here, saying like it must not fall through. Basically, what that means is it can't continue. So you have to use return, but because we're not in a function, returning won't do anything. So if you like if you throw an error, that'll stop the program in its tracks. And yeah, that's basically something we can do. Yeah.
It's like an if statement, but it'll crash.
Pretty much, yeah. Or it doesn't have to crash, it can just return. It can just not execute what's below it. Yeah.
So if I throw NS error, hopefully this will go away. Okay, well it's not in scope, but the point is normally you would throw an error here, but I'm not going to run this because if I try to throw like an error, it might just crash my entire program. So, but just know that usually you'll try to throw an error or like print out the error here in this guard block, inside the guard block. Okay. So, okay, so let's go back to this. Okay, so now we'll talk about loops. So typically, if you see yourself redoing, like rewriting a block of code many, many times, and you have a block of code that's executed many, many times, you can use this inside a loop, which instead of writing, say like I want to print out Peter is 20, and I see myself writing this 20 times. Well, maybe instead of writing it manually 20 times, I could do a loop that loops 20 times, and all I have to write is print Peter is 20. So it's good for like having more compact code. So if I go to Playground again.
Wait, real quick, I think just like clicker. There we go. Sorry.
Okay. So I guess an example is if you use Python, there's like the range operator. And so a similar thing in Swift is there's two variants, the closed range and the open range operator. So the closed range operator would be inclusive. So like suppose I want to do 1 through 10 inclusive. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I would do for I in 1 dot 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 and then 10. Then I want to print out the number I. So this would be, this is the closed range operator. So if I run this, oh wait, let's comment out this.
If you want to quickly comment something out, you can just do commands and then backslash, and it should comment out like that.
Okay, so the last thing it printed out is 10, which means we include 10 when we're iterating. However, let's say we didn't want to include 10 and we want to do 1 through 9. Instead of like just doing for I in 1 dot 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 9, you could also use the open range operator. And then this is what it looks like. So let me just open range operator. For I in 1 dot dot dot, and then it's 2 dots, and then the less than 9, 10. Sorry, 10, but it goes to 9. So let's see what the last value it prints out is. So it was 9. Okay, so other than using like a range of values, what if we want to iterate through the elements in an array? So let's say we have like this staff array, and let's say we want to print out every member in the staff array. So we can do kind of like a for each loop for member in staff. We can print out the member. And so this prints out the last member, which we appended Charles at the end. So this would basically iterate through every single member and print it out. And then the last type of loop that we can talk about is the while loop that you might have seen in other classes. And so suppose we had like our loop variable I. So we make it a variable I because not like a constant using let, because I is going to take on multiple different values over the course of a loop. So let's suppose I starts out as 1, and then when do we want to stop? Let's go 5 times. We're going to iterate and loop 5 times. So let n be 5. And so while I is less than or equal to 5, and let's have like some way we can like something we can increment. So let's have var score, and score will start out as 0. So each time we iterate, if we want to increment score by 1, we can do score, and then score gets score plus 1. And then what you want to make sure is that you want to make sure you're incrementing your loop variable I, otherwise you can get stuck in an infinite loop and basically make no progress. Your program will be running forever and ever, and it's not a good thing, so you want to make sure you increment I as well. Okay, and then so if we run this and want to see, sorry, I used the equals twice. So if you want to see what the value of score is at the end, you can take a look at it. And so at the end, score is 5. Okay, so do we have any questions so far? Yeah.
Why when you print out member, does it show like return Charles?
So it prints out the last member. I'm not really that familiar with Playground, but
Playground specifically, what it does is it just takes whatever's here and puts it over there. So actually what's happening is like it's going through the loop a bunch of times and it's assigning it over there. The computer's just so quick that we only see the last one.
I think it's like it gets overwritten. So technically, if my list only had 1 element, right, it would just print out the first staff member. However, because there's like 5 staff members in that list, it just overwrites it each time. And so the last person to get like printed was Charles, and that's what it says over there. But essentially, it is executing every single time. for
This is
every
also
month.
only in Playground. If you print in like an actual Swift program, it will print 5 times, like what's expected.
Yeah. Okay. Wait, so functions?
Yes, functions. Okay. So yeah, so real quick, I know we're kind of short on time. But that's okay. So yeah, we're gonna go over functions. Oh, my screen just went crazy. Okay. Okay, so we're gonna go over functions. So imagine we have like blocks of code, or we use it like we have a large application with thousands of lines of code, and code is kind of like similar to the for loop is being reused in places. So what we can do is we can abstract code out into a function, and then we can call that function. So yeah, so just a little bit about functions. That's kind of like a little just snippet of how functions look. I'll show you in a demo in a second. Basically, you define a function using the func keyword, and then you specify a return type using an arrow. And I'll show you exactly what that looks like. And then, yeah, you can pass in arguments into the function. So the arguments that you define would go inside those little parentheses that you see up there. And I'll show you that too. So yeah, let's do this real quick. Okay. So let's say we have like a count. So var count equals 0. And then let's say I want to make a func, right? So I declare it, and I want to make a function that's going to increment the count. So I'm going to say increase count. And so if you don't, like if you just declare the function and then do the open and close brackets and don't do a return type, which the return type again is using the arrow, basically like Swift will just know that this function doesn't take anything in and it doesn't take anything out. So what we can do is we can just say count. If we're increasing it, we're going to say count equals count plus 1, right? And then if we look at count, let's just call the function once. So increase count, this is how you call it. And you put the parentheses like this. And then if we look at count at the end of our program, what you'll see is that it is incremented 1. Perfect. So now let's say I want to like increase it, like maybe not by 1, but like by a different amount. So what you can do is you can include an argument to be passed into the function. So the way we do that in Swift is we have to define the name first, and then we say what type it is. So like the name would be like to add. You can name it whatever you want, and then it'll like yell at you if you don't put a type. So I'm gonna say like this is an int. So now it won't yell at me anymore. Cool, but it yells at me down there. And real quick, I'm just gonna add this to the count. So now I'm doing count equals count plus to add, and then here I have to specify what to add is. And it's not enough to just put the number in. I know this is like a very nice thing in Python, but you have to specify like which variable it is. So you say to add colon and then your number. So like 10, let's say. And now if I look at count is 10. Awesome. So yeah, that should be good. Real quick now, I just want to demonstrate like return types. So we have like the arguments, and so let's say I want to give it a return type. What you do is you put this arrow here at the end, in between the last closing bracket or the closing parenthesis and the open curly brace, and you specify what the return type should be. So let's just say for some reason after I increment the count, I want to get like a string. I want to say like, okay, like the count was incremented, right? So what I can do is I can say like, okay, this function returns a string, and I do it like that. And then what you'll notice is Swift is yelling at me again. It's saying that there's no return for this, right? And that's because we need to return something once we define a return type. So we just say return, and we'll say like count incremented. Awesome. So yeah, now we have a return type. So what we can do is this call here is actually our string that we have here because it returns back that string. So what you notice here over on the side, we have count incremented here. We can store this to a variable, so we can say like var count string. I'll just call it that for now. And then we can like figure out what count string is. and perfect. It does the same thing. So that's kind of how we can use functions just very basically. Awesome. And then
Yeah, we are going a bit over time, but optionals is really important, so I'll try to wrap this up pretty quickly.
yeah.
But I guess the purpose of optionals is that we know strings, like you can have the default value be the empty string, but like for integers, is the default value -1? Is it 0? It feels kind of arbitrary. So instead, if we want to have like nil represent nothing, we can do an optional where either it has some value or it's nil and it has nothing inside. And so how this is done in Swift is, like, let's suppose we had a funct, like get favorite sport, and it takes in a name, and it returns a string optional. So not just a string optional. So either it would return you back a person's favorite sport or return nil. So for example, if name is Belle, return, like, for example, volleyball. But else, return nil. So if I call this later on, let's do var fav sport. It's a string. Let's initialize it to this. So if I call this and I do get favorite sport and I pass in Belle, let's run this. It would say the value of optional type must be unwrapped. And so let's say I want to get out the value out of this optional, right? So one thing you should not do is this. This is force unwrapping, which means no matter what, I want to try to go in and like get the value out. This is bad in an iOS application because if like the value is nil, there is nothing inside, this would crash the entire application. So you don't want to do this. In this case, if I run it, it's okay and it would put volleyball. However, let's say it doesn't have a value. Like, let's put Peter here, right? So it's nil. Let's see what happens. And so we get an error. It says execution was interrupted. And this is what I meant by crashing the entire application. So a safe way instead could be like optional chaining. And so what this says is that like if there is a value, then like convert it to uppercase. So if this is like lowercase, right? If there is a value, so if there is a value, do what comes afterwards, so like uppercase. What does it say? Oh, wait, so, one sec. Okay, well it has no uppercase, but let's say we tried to like append cool. Yeah. Okay, but normally if you did uppercase in optional chaining says if there is a value and it's not nil, do this. Otherwise, if it is nil, don't execute. So that's a safe way to handle it. But the second way that you can do it is using nil coalescing. So suppose the value is nil, right? So instead of just storing nil, you could decide to have a default value and store, for example, soccer. So in this case, favorite sport should be soccer. So in this case, favorite sport is soccer. And then one last way I want to talk about is using the if-let statement. So if favorite sport get favorite, if it's not nil, so for example, Belle, then execute this line of code, like print hi. And so this is, if it's not nil, then I can execute, yeah, if let favorite sport, get favorite sport. If it's not nil, then I can print hi. However, if it is nil, then I will just keep executing what comes after this if let block. But you should note that this variable f sport is local to this if let block. So that means I can do things with f sport inside this if let block. However, if I try to like access f sport outside this if let block, Swift should yell at you and say it's like basically not in scope. Okay. Okay, cool. And so this is optionals, and so I guess some to-dos Peter will say very quickly.
Yeah, so A1 is released. It's on the website. If you like have any questions about it, like feel free to either ask on Ed or just like ask me after class. Yeah, submissions are on CMS. Just submit directly on CMS. Zip up your files and put them in. Yeah, make sure to do the partner preference form if you do want to partner for A2, A3, and A4. You are not required to have one, so if you don't want one, it's totally fine. But that is on Ed. The partner matching form should be on Ed. Yeah, thank you for coming, guys. We'll do the Kahoot. Let's do the Kahoot really quick. Just make sure you get in so that we can like get your net IDs down for attendance. Real quick.